I'm actually coming here today, which is my real job. I've actually been working in environment for 30 years. So I've
Oh,
been
wow.
working with green fuels for 30 years and, well, last 10 years. And we're doing a lot of work with a couple of guys, with some of the guys who are from DMET with hydrogen carrying, and also with some of the other replacement fuels.
Wow. So I guess that the topic will definitely suit you. Some very, very interesting insights and story by Prakash Chandra, sir. So, Prakash Chandra, sir, yeah, you can. Uh,
Luke, sir, I don't remember if you remember me. I'm your junior in
How
college.
many years junior, Prakash?
You are Ramandhar batchmate, right?
That's correct.
So I'm 2 year junior to you.
Okay. Okay.
I am in Hong Kong, and yes, we interacted a lot during college days.
We all look very different these days, Prakash. Unfortunately, not as good looking as we once were.
Correct, correct. Age has to catch up, but we
Yes.
have to maintain our health. That's most important.
So you would have been Peter Lobo's batch?
Yes,
Peter Lobo, and yeah.
Peter Lobos, Kosik, Sekhar Kosik,
Yeah.
Sandeep, Kukreti. So now 4 of us are here in Hong Kong. Myself, Dilip Biora, Anand, and Sen Gupta.
Right.
Before we were 8 in Hong Kong, but now reduced to 4. At least 4 of us have shifted to, 3 have shifted to Singapore and 1 to India. Sanjay Kumar has joined owners. And Ajay Chaudhary, Uday Kumar, they have shifted from here. Rajkumar Bose was also here in Hong Kong before.
Manish Saxena was in Hong Kong for my batch for a long time.
Yes, he was a long time here, and then last year he moved to India.
Yes, so I'm doing some work with him at the moment. He's got a great interest in these fuels. I actually messaged him to see if he wants to join today, if he's got time, because this is something of great interest to us. So the floor is yours. I believe time is up. So we look forward to hearing from you.
Actually, Luke sir, my idea was to, I have been here the last 2, 3 weeks, and I saw many juniors are joining here. So my idea was to just tell them the journey, how I reached to the green fuel from from a small town to. That was the main idea. I had told Prateek that I will not be talking about the CO2 numbers and CII but I have been handling all kind of fuels. First of the methanol engine was done under us, and then moved on to LPG, which is having the same platform, and then ammonia. And LNG has been going on parallel since long time. So LNG has always been there. So that was my idea to speak on. You all are experts. I'm not an expert. I'm just just a ship
No,
manager
no,
here.
no. Nobody's an expert. We're all learning our way. So please, I mean, literally, it is such a new field for all of us, and the key is economics. I mean, so I mean, I've really joined because I think your time has started. So please let us not chat anymore. The floor is yours. Yeah.
yeah,
Prateek, is it
thank
time to
you.
start or shall I wait some
Yeah,
more?
yeah, we can start, sir, and welcome everyone. For those of you joining from different part of the world, we have a lot of seniors and juniors today in the session, and more will be joining shortly. We have Prakash Chandra sir with us, roll number 3688, and class of 1989, if I'm correct, with us, who is
Correct.
currently director at Fleet Management, who is based out of Hong Kong, and he has done some extensive work in green fuel, like especially I believe in methanol. He has a lot of interesting story to share with us today. But as we all do, we'll go back in time and we'll start from his journey, how he came to DMET, some interesting stories from DMET times, and then we'll jump back into for the session topic, green fuels. So welcome, sir. Welcome once again, and very honored to have you with us. And welcome to all the seniors and juniors to the session.
Uh, Thank you, Prateek, for a nice introduction. Uh, Good afternoon and good afternoon, everyone. For the people who are on the west from me, good morning.
Good morning and good afternoon, sir. This is
Thank you.
Tamaksha Prasad.
Hi, good afternoon to you. So, Pratik, and we have been communicating in between for some time on some other topic as well. And then he said, why don't you come up here?
Hello.
Yeah, you can proceed, sir.
Okay. So he just wanted to say, how have you? I keep working a lot on all kind of green fuels. So can you say, speak up one day to all the juniors and let them know the journey to start from DMET to here. So to start with, I am from Patna, and everybody, in there either go become an engineer, doctor, or commerce. That was the style. So I also in the race to become an engineer. What was interesting to me was there was a neighbor living by whose son-in-law was a chief engineer in those days. I'm talking of 1985. And we used to meet him and hear stories about, the salaries more than the president's salary, Indian president's salary, free travel, free food, seeing the world. So I had a attraction to join Marine from there. I from Patna, so I had not seen sea so much. I did went to Chennai and some other place, but basically I had no idea other than this neighbor whose son-in-law was the chief engineer. So when the call came, I think it was September, October in 85 for the interview. I went in, appeared interview, got into DMET. And that is how my journey starts from DMET. 3rd December 1985, we joined. And that was the time when sipping, at least for the job, was very difficult time. I had N numbers of my 4th years coming to me and my father telling, this is not the right time, the right place. You go back where you are. And a lot of stories those days. My seniors, many of them got job in 6 months or 1 year. So anyway, we had decided to join DMET. So joined DMET, continued, did my college. Good times with Mr. Kishore, Mr. Viendas, and others. Good experience. But by the time we passed out, just making a story. So in 4th year, there was a situation where everybody has more than one job. There was a situation where companies representatives used to come to our hostel, the 4th year hostel rooms and knock that, please join us, please join us. That was the situation. Well, by the time we passed out, so in 4 year, everything changed. And our batch was only about 60 people. Many people did not join because of all this story. But we were lucky that everybody of us had a job. As soon as we used to pass, go to Bombay, do some training, your advanced firefighting and everything, and join the ship. That was the situation. So initially I started with DMET, with the SCI for a small time on a container with my batchmate Rajiv Verma. But after 3 years, I fell sick and I had to sign off. So initial 3 year, those ships had 72 people, nothing to do, no work. As a 5th engineer, we used to be in white bowler suit and hand gloves, which is now can be a dream. But that was the time, those days in engine room, we used to have more than 30, 35 staff. 2 fitter, 2 additional fitter. I don't know how many people. It was like a live life king size. But it was a bit boring because, no work for us. So after 3 months, me and one of my batchmates, was here, I think he's here. We decided to crack a UPSC. And this was a time when we got time to stay in India at home for almost 2 years, where we learned how the government is running. Before that, in DMET, there used to be no leave. Before DMET, we were young, so we were not seen. Whatever we saw and whatever happened to our exams, both of us decided to join back again. So this was 92. And things have changed now. Their batches after us came with 120 people strength, and there are not so many vacancies. But anyway, we both of us got the job. I joined Anglo. And I'm just saying how I'm reaching to green. I will come to that. I joined Anglo and they put me on very nice ships, very good food. All was good until 95, I was waiting to join a ship named Mineral Diamond. And there was some delay, there was some deviation. So I was waiting in Bombay. I had completed my LPG advanced course while waiting for the ship. So 2 days before traveling to Mineral Diamond, Mr. Menon called me, told me there's one guy on a ship named Newbury, to the LPG ship. He has broken his hand, third engineer. Can you go and relieve him? So this was a small ship, 2,000 cubic, very small ship. And when you normally you talk, I also spoke to my batchmates, said, hey, what kind of ship is this? Everybody advised me, you run away, you break your hand, foot, whatever. This is a very bad ship. Don't go there. Those were the initial days when LPG was coming to Anglo. There was only 2 Indians on board, another Indian second officer, and the third engineer was broken his hand. But I have never asked in my joining time, used to never ask what the ship, what kind of people. I said, see, I've been selected, I'll go. So that is how I got into gas. And I went to join the vessel. She was in a port where we came to the jetty. There was no ship. I said, where's the ship? Agent said, look down. The ship was down below. This was first ship which I joined by a pilot ladder. I had to climb down to the deck. It was such a small ship sailing in Mediterranean and Bay of Biscay. But at the same time, you see how the life takes you. The Mineral Diamond, which I was supposed to join, had a very unfortunate incident. Many other people know. And my life was saved. I don't know, my other seamen could not. But I came here. And that is how I started my LPG career. Then I worked on LPG ships throughout after that, except one ship where I had to go for my kilowatt rating, because this ship's very small. So I could not appear for my exam. So I had to go to one container ship. But after that, I kept sailing on LPG ship mostly. I did my exams. And, I had not sailed for some time. So I finally did my exams. I got my tickets in 2000, which was very late for that standard. I was quite behind my batchmates. So this Newbury, which I was sailing, was sold. And there was a case, the buyer lost the case, that it doesn't work, nothing works. I was sailing on one of the best ship on Anglo-Stern, brand new gas Dyna. I joined the vessel after doing my exam as second engineer at Boni in Nigeria, and ship sailed to Singapore. And then I got a letter of promotion, telex of promotion by my chief engineer, which was, I had just sailed for about 34 days. And it was not normal in Anglo-Stern, So anyway, so I got into this Newbury, went there, Malta, we repaired the ship. It was ship owned by Petrodic. And why Petrodic, I'm mentioning here, I'll tell you again. So we did everything, and ship was made, put in service, went running. I did my 2-3 shifts more. I always want to join class. One of my batchmates told you, ABS is best paying. It has got the highest overtime when you go to offshore rigs. So you keep trying for ABS. So every time after I did my ticket, I used to come to Bombay. I never used to go to Delhi. I'll go visit ABS office, Mr. Bhamnani, then go home. Come back to join ship again, ABS. So anyway, so ABS offered me job. I joined ABS. And while I was in ABS, one of my batchmate, he said, come to Fleet. And Fleet was all Indian setup. I think that time they did not had any LPG, or they're just taking LPG. I was thinking that I am a gas person, so I can run reefers. So I joined the reefer fleet of Fleet Management in 2004, September. Then that time we had no gas ship. Anyway, we took some gas ship, and year came 2008. One of my owner, who had one small LPG by the time already, Petrodic, had ordered 5 ammonia tankers, out of which toward the end they left 1 ammonia tanker. And my owner wanted to buy this ammonia tanker. So we did everything, design review, drawing review, finally did the cost negotiations, what owner wanted. We got price down by $1-2 million. And this vessel was bought, which was a pure ammonia carrier. And from there, we went on. I went on, and then we had a methanol tanker. It was pure methanol, phenol epoxy coated tanks. No, sorry, zinc silicate coated tanks. And one of the Swedish owner bought the ship for largest methanol producer, Methanex. This Swedish owner had 6 more ships, which are all running under Methanex, who is the largest methanol producer. By chance or what, this Swedish owner had all crew with Filipino crew. They are very good owners. They are one of the best owners I have ever seen in my life. But they had all ships with Filipino. They had a very good training facility in Philippines. But our ship was an old ship, and they thought this cannot be run by Filipinos. So they leave it to us, and we started running this ship, methanol ship, on Methanex time charter under waterfront shipping. Then we interacted, we worked together, and then they realized that these guys are good, somehow. What Indians are, I can say proudly, DMET, we are Indian. We have brought the shipping here to all the junior batches, what we have done. And Methanex wanted to promote methanol to make as a marine fuel. But for marine fuel, there has to be a marine engine. And that time we were not thinking about CO2 or CII. All these things were not there way back in 2012-13. When the concept started. It was done by a guy named Frederick Stubner. He is now with Green Marine. He was ex-chief engineer from Ferries, and he was the owner's director for ship management. So he, Methanex, and MAN, Peter Quad, and Keld Abo, they all started on the first project, how to go about this methanol, how to make it as a fuel. Because for methanol to burn, you needed double the volume, and then there was other limitations. So instead of going for a fuel pump, because methanol being not so good for lubricity, they went into the fuel booster injection valve. That is how the concept of methanol, LPG, ammonia for MAN is this fuel booster injection valve. So that was developed first before developing the engine, how to make possible the injection. So supply pressure from they call it low flash point supply room. From there is only 10 to 13 bar going to the engine. There is no fuel pump. This one unit, which has got injector as well as pump on the top, together one unit, was developed, designed, and then the first running engine, single cylinder engine, was started in 2014. So Mr. Frederick used to live in Gothenburg. From Gothenburg, he used to drive down to Copenhagen once in a week to sit together with a man. I also went 2 or 3 times to study this one. But by the time we were promised, Mindwest were making 2 ships. Total 6 ships were built. 2 went to Mindwest, 2 went to Westfall Larsen, and 2 went to MOL. But Marine West and Thome, they had some family friendship, something. First 2 ships, one of which was for us, one for that, it went to Thome, both the ships. My all Thome friends know. But finally, 2019, we got our first methanol dual fuel methanol MR tanker. And 2021, we got our second. So tier 2 and tier 3 methanol engine we are having now, we are operating it now. And at the same time, we also got the LPG dual fuel VLGC. And this was again on the same principle, FBIV, the fuel booster injection valve, liquid gas injection principle, but little bit different in the concept. So now there the fuel pressure was 13 bar coming from the fuel gas supply room. LPG, it is 50 bar. And basis on this LPG concept, ammonia concept is being developed. So, I'm not talking about the CO2, how much, and CII, and what is reduction, just the concept, how it was developed. So I was there in the picture all the time when this was happening, directly with the maker, the concept, the design. And then 2021, during COVID time, this Sumitomo wanted to start a project for making ammonia as a fuel. The Sumitomo being one of the largest bank in Japan, and they have various interests. They are also producer of ammonia, methanol, so many others. They are ship owners. They have everything. So they wanted to start this concept of methanol as a fuel, but to develop fuel, they needed the buyer, the ship owner. So same time, Musk was working on both sides, methanol, LNG, and something else. So something else was ammonia, which was guaranteed no carbon. It was guaranteed. What will happen later, nobody knows, but at least guarantee what carbon. So Musk came in picture. They gave the requirement of ammonia, that how much ammonia they will need in 27, 28, or 29, how many vessels they will build up to run on ammonia. Because without, as Luke sir said before, is all economics. If there is no ship, who will give why to make ammonia if nobody is willing to make ammonia? But the ammonia having this fear of toxicity, and you must have been seeing so many questions. I was in Houston recently. People are totally against it. It was like a challenge to start it. So 2021, that is how. So Sumitomo was looking for a consortium, and we made the first consortium in May 2021 for ammonia, to develop ammonia as a fuel. So this is how we reached up to ammonia. And once we started, so methanol has already matured by this time. LNG is already matured. You have 2-stroke design, 4-stroke design, everything matured. Methanol is still, the 4-stroke is not so mature. It still need, Wärtsilä has their own concept, and MAN have their own concept of 4-stroke. Because of large volume and reduced time of combustion in the 4-stroke design, still it is not very popular for the generator. It's still mainly being used as fuel on 2-stroke large engines by mostly MAN. So methanol went there. LPG is already developed. Already the FPIV concept with LGIP engines are running now. More than 40, 50 ships are running. So now comes the ammonia. So ammonia, the challenge was to win the people. One challenge was the concept to develop. Like we started first year in 2021 in Singapore, and the government was also not interested at that time. Ammonia in Singapore, landlocked, sea locked from everywhere. Something happens, what will happen? So to build up ammonia as a fuel, we were the first consortium in the world, which we started, but Singapore government was listening to us. So every month we used to have a consortium meeting, and Singapore used to pass on all information to the government. And by end of the year of 2021, MPA was very interested. I think GCMD was formed about similar time, and 2022, I think. So MPA already became interested, and we signed our second MOA, including MPA, Sumitomo, Maersk, C-SPAN for short time, Yara, ABS, MAN, and Keppel together to develop ammonia as fuel. By end of the first year of 2021, which was our first project, first MOA, completion of that, Singapore NPA was almost convinced that yes, ammonia is not going to be so dangerous as people say, and it can be developed as a fuel. And once MPA came into picture, then they joined. They are sitting in our consortium now. Now we're running the third phase of the same consortium. So first consortium for 1 year we studied only all the concept of ammonia. What is different? Because we had people from K line, so LNG. LNG concept is totally different when you compare ammonia with LNG or ammonia with LPG. So that is what we were trying to convince the governments, convince the ship owners, convince the shipyard who could agree, yes, we accept ammonia first. So that is how we reached a stage where now ammonia is being considered as a fuel after the most credit goes to Singapore MPA, which drove it very hard. They used to have their people sitting in the consortium. They called us all to Singapore, all the people it was COVID time. Or just after COVID time, we went to Singapore, all of us sat together. MPA represented themselves with large number of people, and we all sat together, agreed on it, and now we are developing the concept together for bunkering, and at the same time, crew training and the risk analysis. At the same time, the dispersal studies was done. See, when you are considering any bunker, ammonia is being carried as a cargo for a long time, more than 40 years. Being carried as a cargo. But if you're doing it operation every day, you're doing it, the risk is transfer. The transfer system is at the risk. The main weak link is your hose, the manifold, that's all. Remaining everything is same as ammonia is already being carried on the LPG ships. So this risk was seen properly. The hose were tested, and what can be done so that if there is a rupture in hose, how much will leak out in 1 minute, in 5 minutes, all these calculations are done. How will it disperse in daytime? How will it disperse in nighttime? How will it disperse if the wind is flowing towards Singapore? How it will, all these studies were done. And now, as you know, this year, the government and the energy department in Singapore have already announced that they have selected 2 consortium, one led by Keppel, one led by Sembawang, to develop ammonia bunkering vessel. Right now, we are working with shipyards to develop the design of the ammonia bunkering vessel and ammonia tanks. Advarde will make 2 ammonia tanks in Singapore, and PA is giving them the place on the east. So on the east side, this is how ammonia developed. On the west, the port of Savannah is the 3rd largest container port and the car carrier port in US. So Port of Georgia was interested to develop ammonia there. So in US, especially in Savannah side, Savage and Tute were already doing bunkering of LNG. So again, Sumitomo as a lead came and with Port of Georgia, ABS, Savage, Tute, we joined another consortium for developing ammonia as a fuel for US East Coast. And now we already have a design in place, and this will be bunkering vessel design is confirmed. This will be built for US, only US trade. So it has to be built under Jones Act. The ship will be built in US. The cost will be quite high comparatively, and the time is also quite high because a long time US has not built any LPG vessel. So that part is also confirmed now on the east coast of US for ammonia. And for the west coast, we are again working with a company called Calamco. So Calamco is the largest importer of ammonia in US. So Sumitomo, Calamco, Port of Stockton, Tote, we all have again formed a consortium to develop ammonia as a fuel on the west coast of US. So this is how ammonia is developing. Now come back to methanol, because the future everybody's talking is there are only two, ammonia and methanol. So methanol, already infrastructure is available everywhere. They have got more than 85 ports where already methanol business is being done. And if required, methanol, like our methanol ships, like in Korea, when the first time they were using their bunker from the cargo, they're loading methanol. But then we decided, or the charters decided, that we must do separate bunkering. So we wanted to do first bunkering in Singapore, but Singapore MPA did not have the rules for methanol bunkering in place till this year, January. The first rule, no, last year, January, the first rule came in March. So we did the first direct bunkering in Korea from Seoul tank to our ship. We gave all the reports to different authorities, including Singapore MPA. And now MP Singapore is doing the ammonia methanol bunkering. Also in Rotterdam and Amsterdam, not problem. The main problem with methanol is what they call energy required to produce 1 joule of methanol. Energy required to produce green methanol is much higher than what is required for ammonia. The concepts are, there are still studies on. People don't know if that will improve and methanol will become cheaper than ammonia. But as of now, that is the situation. And the main authority for methanol worldwide is Methanol Institute. Methanol Institute work with all methanol suppliers, all methanol transporters, all methanol users as one institute, Methanol Institute. They make the rules, regulation. They have the relationship with all the people who are interested in methanol. So they are working with all the producers and future to green methanol, how to make it cheaper. They are working right now. But if you go to the Methanol Institute website, they have the figures available for methanol availability of green, gray, blue methanol until 2029. And I believe now they will produce 2030 also. But after that, there is no figure, because until last year, there was a large order of methanol powered ships. Last year alone, they ordered, I believe, more than 232 ships were ordered for methanol. But this year, until now, only 70 orders have been placed. Methanol took backseat once Musk put their methanol powered container into service. And when they wanted to get the green methanol, they're having big difficulty. They had to ship the green methanol from Rotterdam to Suez to bunker their vessel. And the cost was, per ton was so high. Similarly, when they had this methanol plant, which they were developing in Denmark, they had to close it. The methanol producer closed the plant. They said it is not possible. So methanol has just now taken a back seat, but will not remain on back seat. It will pick up. It is going to pick up. It's just like right now, there's like a situation where people are just watching. So that is the situation right now with methanol. With ammonia, because of the production process, right now the production cost is lesser than gray methanol. Gray ammonia, the production of hydrogen is by the renewable source, by the renewable energy, is much cheaper than even ammonia. But ammonia is not right now being treated hydrogen. But with Sumitomo and other consortium partners are very positive that the green ammonia production will not be an issue, and the cost will be comparative or a little bit more than what you have for LSMGA today. They are looking. So there are study going on with the countries across the globe, not only east or west, everywhere, where Sumitomo and okay, I'm not promoting them, so but where the producers are joining together and they have figures in place where they can say how much methanol we'll have in 2030. Sorry, ammonia, green ammonia, 30, 40, and 50. The gray ammonia is good until 2040. So that's the future for ammonia. Methanol is also good right now. With what they are talking now is mixing green and gray methanol. Don't use everything green because it's very costly. And you can, it has been already studied, tested. You can mix green and gray methanol and then burn an engine. So that is one concept working for methanol and another concept working for ammonia. Ammonia, as of now, looks like it will pick up after 2030, but the production will not be a problem for ammonia as of now. What the studies, what we have received. Methanol studies going on. Then comes the LNG, where people are trying to produce e-LNG, green LNG. And another concept is to remove carbon from LNG and use hydrogen only, or remove a part of, you use 1 ton LNG. From 1 ton LNG, you remove 400 kg of carbon. That hydrogen you add in the LNG, which is going to the engine, mixing, and then you have 60-40 ratio. By this way, you can reduce up to 50-50. The carbon which comes out is not liquid. The problem of carbon is storage. The problem with carbon capture systems is storing the carbon. If you either store as stone, you store as liquid, and mostly the system which is available now is by liquid, which is a large volume and difficult to store because at the normal atmospheric temperature and pressure, you will need tanks, safety valve setting at 18-19 bar, heavy tanks to store the CO2 liquid. With the H2 LNG reformate process where carbon is removed as a powder, they are developing a system where the carbon can be stored in ballast tanks, like what you have on your grain carriers. And this can be sucked out from the tank as pure graphite and can be sold. So this concept is right now being studied, not fully developed. So, but this is one way of making LNG, which I was thinking that LNG will never be green, but one of the way from existing LNG, they still call it gray LNG, the gray hydrogen. They don't call it green hydrogen because carbon is there, which has to be handled, and there is no system in place right now. But that is one of the concepts working for LNG to make it more greener. Other than that, batteries. Yeah, this is what I have seen. But what I have reached here, I wanted to say that I was just a marine engineer, but somehow the destiny took me this way, where I came into the middle of the happening of the green things.
Thank you, sir, for sharing such an amazing, very, very insightful talk. So I just want to know, a lot of people write to us on DMT Club that they want to switch to gas carrier or green fuel, but employment opportunities are very limited. So if someone wants to make that switch as a sailor or as a superintendent, how someone can do that? Or can you help someone transition to a green fuel carrier path, or what will be a look like 3-4 points that someone has to follow to get there?
See now we are running now about 23 dual fuel ships, which are out of 23, eight are tankers, remaining are not. But we are preferring people who have a prior experience of working on a dual fuel LNG ships. because they are more in numbers, right? So they are number one preferred, but they are very expensive to take in on a container ship or a car carrier or a bulk carrier. But anybody fresh who wants to join, he should have at least as a basic, for methanol, you need the chemical course. If you have advanced chemical course done already, it will help you. For LPG, LNG, you have to do the advanced gas course. If that you have that in hand, then when a company is recruiting, at least you are one stage ahead. If you are coming from a dry fleet or a oil tanker, gas tanker people have no problem. They can easily switch to any of the dual fuel vessels, but the problem is the salaries. So like when we are now taking some car carriers, dual fuel car carrier, we are also preferring, or the owner is asking, why don't you send people who have the experience on dual fuel engine or LNG engine? Then the cost becomes high. So that's challenge remains. But if you have a gas course done, you are one step ahead. And also the IGF course and advanced gas course.
Anyone has any question to ask to Prakash sir is like more than welcome to ask.
Good afternoon, sir. My name is Utkarsh Mishra. I am presently working with MOL in the commercial department. I was sailing earlier on LNG vessels with Dynagas, Shell. Mostly, lastly, I was sailing on this mega engines and Wärtsilä XDF engines, dual fuel. Presently, I'm working on a contract with Reliance for their ethane carrier, and we are trying to get a MAN engine with ethane burning. So my one question is, sir, as you said, for ammonia and methanol, they are using FBIV principle because of the lubricity problem. So in case of ethane also, there will be a same issue?
No. So we were the first to make 98,000 cubic ethane gas tankers, 3 at Hyundai and 3 at Samsung. This 6 vessel, the main engine is running on MEGI E principle. This is called MEGI ethane because MEGI ethane engine has the normal MEGI engine. The fuel supply, the LNG supply pressure to main engine is 300 bar. MEGI ethane, the pressure required is 380 bar at the engine. So they don't have FBIV. So their fuel gas supply system is that you take the liquid from tank and press up in the pump to 380 bar for ethane tankers. So the Reliance which they made was they made only ME engines. They did not make the engine running on ethane gas. But now all the new ethane gas tankers, first delivery was 2021 March. Onwards, all ethane ships which are built, they all are ethane fuel. So our vessel was the first vessel which was having for high pressure pump was for the MEGI system. Even now the LNG ships which you take a dual fuel tankers which has a MEGI engine as an LNG engine, there was a problem with the fuel injection valve and the high pressure. Why Mega came? Mega came because people were afraid of this 300 bar running from middle of the main deck to the engine room. Though until date there has been no leakage, but people have this fear for which Mega came or XDF came. But the MEGI engine, so what they developed now, MAN developed a thing called PVU, pressure vaporizing unit. This runs on hydraulic power. The moving parts are very less. So this is like a Framo system. One side is the cold side with minus 90-degree liquid. One side is your hydraulic oil. And these 3 cylinders are running continuously, developing 380 bar pressure with very low vibration. Pressure is 380 bar, but that fear of vibration is gone and high power required to run the high pressure pump is gone. So you're running a normal hydraulic pump, same like Framo, and that is pumping this 380 bar pressure. So if the Reliance wants to change to ethane, they will have to add this high pressure MAGI system on the. It can be modified.
So
All
this
Reliance 6-slip can be modified.
this PVU, sir, which you said it is installed inside the cargo tank or in the compressor room somewhere?
Like compressor room. They call it
Okay.
cargo machinery room, right?
Yeah. Okay.
Yes, there.
And sir,
But
what
it
you said,
needs.
yes, sorry, sir, please go ahead.
No, you go ahead.
Actually, my second question was, sir, as you mentioned for the LNG, since I was from the LNG background, we have noticed that, I mean, we have reduced the carbon emission. But in order to reduce the carbon emission, we have led to the increase of methane slip. I mean, especially on the XDF vessels, the methane slips were much higher. And methane is, I believe, it is much more dangerous than the carbon.
True. So that is what I said. The people got afraid of this high pressure and went to the low pressure, forgetting that the low pressure, the slip, whatever XTF claims, or whatever MAN came with a mega engine that you have reduced to XDF, say now they've reduced from 2% to 0.5%, which is not true. It is not true. It can be proven now. So that has, where MAGI has been saying always 0.5 and it still remain at 0.5 slip. So now that's true, and methane is a problem. So systems are being developed to do something different to reduce the slip. So one of it is the EGR, where now all the mega engine have EGR, and also I believe XDF are having EGR, and they are now making a study to add hydrogen. So hydrogen improves combustion of the inside the cylinder head. So there is a planned study being done, and there's small, there's like a hydrogen generator which can be installed in a container type of thing are being developed. So together with LNG, if you mix hydrogen or can make a provision to burn hydrogen in the cylinder mode, inject cylinder hydrogen, the methane slip is considered to be less. You know about the Wärtsilä DFD engines,
Yes, sir.
the four-stroke engine.
Yes.
They have already developed a program which allows you to burn 25% hydrogen mixed in LNG without any changes. Also, they are developing, they are redesigning the cylinder head with spark plugs. So a spark plug will help you to, because the four-stroke engine, the slip is almost 3.5 to 4%. So they have redesigned the cylinder head with a spark plug, and they have been able to reduce by a big number the methane slip. Methane slip is a challenge, and processes are being developed to, because you have to show it to the fuel EU is coming. You have to show how you're reducing the slip. It has to happen soon.
With methane slip, I mean, I came through a study that Hyundai, they have developed in their engines this MSS methane slip solutions. And I don't know how effective it is at the moment, but they have done some improvement in this.
No, they are effective. They're software solutions and they are effective. Even Wärtsilä has developed a software solution to reduce methane slip.
But with this development of this EGR, this exhaust gas recirculation, I was working on a mega vessel. It was one of the first series of 6 units mega series, and this EGR was a hell lot of trouble, sir. It is not still stable. And with mega engines, the kind of vibrations we have, they have LG, LV, and this fuel injection, there is plenty vibrations. So
I know we are having now 4 ships. Our sister company is having, and yes, but when we started first methanol engine, or when we first started, for everybody of us, I have the experience. When we started ME engine, I remember I had to stop one ship for 3 days waiting to get part. When we started the methanol engine used to run maybe 1 day, 1.5 day max. It used to fail. And it took almost 5 years for the first series engine, which we can say now, the methanol engine, first series running good, third series is running good. Second series is still we are not reached to the comfortable level. LG IP, the LG LPG engine, you ask everybody who is sitting here if they are running the dual fuel LPG. It was real pain till yesterday. This ship will never run. Max 8 hours, max 10 hours. And the charter party, now the charters are coming with a huge penalty if you're not running on dual fuel. So these challenges will go up slowly, slowly. So now we have found a solution on the LGIP engines. Now we have two LGIP ships which are running continuously on dual fuel. One ship is still we need to make the developments. So time, it will change. It will. So nobody was putting focus on methanol, methane slip. Now everybody is putting focus on methanol slip. You will come to know ideas. I never knew that, you can install a spark plug on such a huge 5,000 kilowatt four-stroke engine. We are doing it now. We are changing our DFD engines to have the dual fuel, the spark plug. And reduction is from 3.5 is going to be less than 0.5. That is what they're saying. It's a huge, huge reduction.
Okay, sir. Thank you, sir.
Welcome.
Prakash, I have two questions. One is
Tell me, sir.
dealing with biofuels, and you all haven't talked about the input of biofuels. I realize the price could be one of the main factors, but it is one of the big drivers at the moment to go to biofuels. The other one is that I do disagree with one point which Sumito will make about the cost of green hydrogen. We've been working with green hydrogen. Currently, it's around 6 times the price of any other fuel. And that's simply on one particular thing, is that I'm living in a country where we have ample sunshine. Australia is known for it. Our price of hydrogen is based on the lowest green electricity cost. But the problem you have with any hydrogen machine is it has to operate for 4,600 plus hours a year. So as you know, with shipping, you're going at 8,000 hours. The sun only shines for 2,700. And once you move to batteries, once you move to dual green energy, the price absolutely shoots up to above $8 to $9 per kilo of hydrogen. So this is why we see green hydrogen probably right at the bottom end of the chain today. But that's by the by. As I said, you all are talking to Sumitomo. I would love to know where they're getting their numbers from, because I'm working with a couple of Japanese consortiums, and I've been telling them, quite frankly, look, get for biofuels, etc., because this is down the track. But I'd love to hear what you're talking about with biofuels, because that is one that we see is the easiest to embed into the marine field.
Okay, the first for hydrogen. So the cost what we have received from, I'll share with you later after the presentation. They are saying that at present they're able to produce at $600 per ton. This is coming from MAN, not from Sumitomo. So I will share their presentation where they have said, and I'll also go into them and ask them that in more detail. I never went to them because they have presented this cost in many forums and nobody has objected. So I think this should be the cost. The problem is, what I understand is the quantity required to produce same energy and the storage. So that is why on the hydrogen, we are looking at a solution where you don't have to store hydrogen. So if you have an LNG on board, extract hydrogen, mix with LNG and burn, no need to store. So that one I'll come back to you. For the biodiesel, we ourselves.
Just before you go further, I'll give you some numbers which you can take back to them. The two ways of mass producing hydrogen are from steam methane reforming and from coal gasification. Coal gasification is the cheapest. It's about $2 a kilo, $1.50 a kilo. Steam methane reforming is $2 a kilo. So we're talking 2,000 a ton. And these are the cheapest. This is what you can do in Saudi Arabia and stuff like that. We then get into what you're talking about with the green hydrogen, and we have got documents here in the Australian government and stuff which are saying our aims are to get to $2 by 2032. So if they're at 60 cents, I would love to hear what they're doing, because it's pure magic. It's beyond our technology capabilities that we know of. And I say this because we have to be cautious. As marine engineers, one of the first things you learn in DMET is never to trust bullshit, because you're going to make decisions tomorrow on it. So the issue is that what you've said has been extremely educational. as to where you'll have gone with methanol, but this one factor of the cost of hydrogen seems absolutely out of the ballpark. So this is the first one, and I would dearly like to know where they've got their costs from.
Sure. So as I tell you, I'll come back to you because I, as a consortium, we are not working on hydrogen at all. We are working only on ammonia. And the hydrogen study is separate, which I am doing with another company called Rotobos, who are making it by reformation, of course, by same steam heating. But the mixing is there. Second question is your biodiesel. So we have consumed about more than 3,000 tons of biodiesel on our ships. And the experience has been extremely good. And it was all arranged by charterers. They had the fuel they could supply. We have used it on 3 ships, 3 bulk carriers. So we have no complaints. But what, again, I am not pursuing biodiesel. But what I hear and what is my understanding by going to so many forums, that when biodiesel actually comes in mass number, they all fear that aviation will take it away. There will not much remaining for marine. So people are not trying to invest so much time and on this dual fuel. If they're getting some, they're happy, but they don't want it to make it as their primary fuel. That's one of the reasons for this is what I understand for biodiesel. But as far as our experience, we have no problem in using biodiesel, except the Cashew products where we are having problem with filter choking. Otherwise, we are okay with biodiesel. If it is available, it is the best fuel for the marine industry.
I think you're absolutely right. I mean, I have been involved with IATA on the SAF, and SAF is about 4 times the price of sustainable aviation fuels, are 4 times the price of marine fuels. But we were talking to a number of parties, hoping that there would be some level of investment from the marine industry towards developing biofuels in places. But I just thought that way, that's one way you can guarantee your stock if you own it.
Yes, that's correct, if you own it. But if you get, as I am not pursuing it, this is what I heard from industry.
Thank you. That's answered my question.
Thank you.
Anyone has any more questions you'd like to ask Prakash?
Prakash, I'm Henry Tissa. I've been with the Hartmann Gas. They are mid-sized gas carriers, especially in chemical gas, ethane, ethylene downwards, ethane, propylene, and down to BCM. I've also been a construction manager with Bhumi Armada, where I did the integration with gas turbines, 21 megawatts, 11 kV to 440 volts into the engine room. One thing I don't understand in the industry is we are talking about gaseous fuels. Why are you not embracing gas turbines? And why is that obsession towards 2 strokes and 4 strokes? Is it because of the capability, or is it because of the herd mentality, or what is it?
Again, difficult for me to answer because out of my field. But what I understand is that for the marine community, like, say we are changing only fuel from traditional fuel to say LPG, or traditional fuel to say easiest on methanol. And there is so much challenge with respect to training, with respect to handling. Let us not talk LNG, LPG, and ammonia. Only methanol as fuel, we are talking on a car carrier or a dry bulk ship. It is a challenge, because the fuel is different. And to train the crew to understand the complexity of methanol, the toxicity of methanol, different way of handling, dual fuel pipes, associated nitrogen generators, your this methane sensors. So this is such a small part, is a part of the our normal engineering, but for the crew it is so different. If you change to gas turbine, it's going to be totally out of field, because gas turbine is mostly used, what I see on the Navy ships, especially high-speed frigates and all. I've seen gas turbines. But in marine field, even we on some of our LNG, which I have not handled, but yes, I know those LNG which had the gas turbines, it's not so.
Can we from the audience also participate if it is permitted?
Yeah, please. Please.
Sir, I didn't want to be rude to interrupt you, sir. You can continue. After that, I'll speak, sir. With
No,
your
so that is
permission.
what the question from Henry was, that why we are not considering gas turbines as a source of energy or to run the ship. So this is what I could think of. Nicole, if you want to add something, please add.
Sir, with your due permission. Actually, merchant navy has significant application of gas turbine. The gas turbine, which is generally used for most of the merchant navy or frigate applications, are different from the applications which are mostly used in aviation industries and others. The industrial gas turbines are not aeroderivative; they are cannular, and they don't have a cannular constructions of the combustion chamber. The major thing which is withholding the application, which was withholding application of gas turbines about 10 to 15 years back when I first became chief engineer, was the cost of the fuel to start with, and the relative lower efficiency even with the combined cycle, Kodak, Kodlag and other cycles, combined cycles. But the diesel engine, also the diesel engine lobby was very strong, and they were giving very good facilities like component finance. Probably most of the people who are doing shipbuilding consultancy may be aware that they have the MN BMW has its own bank which gives loan for ship owners or small time ship owners to buy, and also experimental engines they give almost at throwaway prices. That is one economic consideration. Second is the combined peak cycle efficiency, which is at 52% in the prime mover section of the engine, even with the let us say liquefied or compressed gas stratified ignition engines. Now coming back to gas turbines, sir, there is a combined project of Wärtsilä, Daihatsu, and Yanmar. That is called the SMGT, Supermarine Gas Turbine, SMGT. Yeah, SMGT project. Anybody can Google right now as we speak. And SMGT project has been going on for a long time, and they have come up with a industrial gas turbine with higher efficiency, which can burn LDO and marine gas oil, MGO, and also burn MGO, that is MDO, that is DMA 8, DMA B8, DMA C of ISO 8217. So this kind of the fuel category cost itself was the initial deadlock. But if you have a industrial gas turbine where the combustion chamber is not an integral part of the gas turbine architecture, being gas turbine being extremely compact, gas turbine is about 5 times lighter with power to weight ratio compared to a two-stroke cross-head diesel engine, single acting direct injection. So, and also in order to repair, the concept is very simple. You don't overhaul the engine in place, you just replace the entire cartridge. That means the full container or thing step by step. So it's a very popular thing in RoPax vessels and RoRo vessels of Grimaldi lines, which have already gone for gas turbine application with, I would say, the azimuth propulsion system or the combined power plant concept, where they are having multiple gas turbines and diesel engines as the power pack and combined high voltage central bus, from which electric propulsion in azimuth propulsion systems are being done. There it is one of the most favored application, because in that case we have to limit the size of engine room and limit the overhead structure required for overhauling and maintenance. So this takes care of the first question, whether it has been used or not. Yes, it has been used, and it is very much applicable in the present sector. The reason being why we Indians are not exposed, that we are not in the cruise ship sector. To be very honest with, none of us, let us say brown skins, are there much into the lucrative cruise liners and others where the actual application of the gas turbine is. If you see the oasis of the seas and others, that is where most of. And secondly, gas turbine application is prevalent in all the HSC, high speed craft, passenger as well as cargo. Any application with the jet propulsion systems with 15 degrees leverage of the nozzle generated as gas turbine. Number 3, captured air vessel bubble vessels, that is the hovercraft. Hovercraft means with the skirt kind of thing, which floats on water, high speed. All of them are gas turbine propelled. And number 4, electric propelled vessels, Queen Victoria, Oasis of the Sea, this something of the sea, whatever these people keep on hitting, they are mostly gas turbine propelled. So this is my humble submission. I may be wrong. Seniors can correct me.
Nicole, I never
But
said
the
that gas turbine. I said it is not a popular or mostly used way of propulsion on in the merchant navy. You know, even there were LNG ships built with all turbine, and the same way all the turbine used to go every 5 year land ashore, finish, take another one. So
yes, sir,
I
that
did
is
not say
correct.
that, but the way, and as Luke said on starting, the economics we don't know is not so popular. That's why it is a bit difficult. That's what I don't know about the efficiency wise, because for me now the LPG ships, the LNG steams are most inefficient turbines. Maybe gas turbines are more efficient, I believe.
So just to
Sir, the
intervene here,
SMGT alone has a peak cycle efficiency at 990 degrees centigrade peak combustion temperature for about 45%. That is maximum which has with SMGT has gone that to in trial condition. But if you go for combined cycle, it is rivaling the diesel engine. Now, diesel engine lobby, in order to thwart this expansion, what they have done, all the major manufacturers, what are the major manufacturers? Wärtsilä, Sulzer, MAN. They have colluded together and have launched the Hercules project. And this Hercules project will have a peak firing temperature of peak firing pressure up to 50 bar and a compressor pressure in the excess of 100 bar, where the starting air pressure itself will be more than about 40-45 bar, what we used to have in submarines, in order to start that, because the general what we say the PLAN, the average pressure of the engine is increasing in this case. So the starting has gone up, and that kind of engine, it is being said, will give you more bang for the dollar. That means the peak cycle efficiency is supposed to go from the present ceiling of 52% to a maximum of 65%, given the electronic stratified phase-wise combustion system, which has done significant research has been done on the droplet combustion model, where and also advanced metal coating, which has prevented the initial failure temperature of 550-degree metal temperature for exhaust valve and other places. So even that thing has been raised to about 700 degrees, and the loading of about 10 tons per square inch that was being given for pre-compression in order for the high temperature resilience and other of the exhaust valve seat cones with the air, what we say that combustion air, sorry sir, I'm forgetting the term, that is the ceiling air.
That is too much technical, you know. Anyway, we have so much talent here, you know, that is why our Dmetians have started this club where people can join in sometime, share the experience. And yes, we have a lot of experience. We have people in right places, and we all of us can do wonders. I completely agree. I will say, Nicole, thank you so much. And we can have, Pratik can arrange a separate discussion on the gas turbine sometime.
Definitely, sir.
Thank you, sir.
Definitely, we would be arranging that. And if anyone has any question you want to ask Prakash, sir, because it'll.
Henry has finished.
I just wanted to put in a few words here that, as senior Dmetians, we should look at capability development for our Dmetians in different fields, not just in diesel engines, two-stroke, and things like, and just straight career pathways from a chief engineer to superintendent to this thing. Here is gas turbines. I have one of my batchmates from DMET, A.K. Roy, who is no more, God bless his soul. He moved into gas turbines. He joined ONGC. He rose up to be almost close to becoming a director when he lost his life during COVID. And his life path was pretty spectacular. And that's where I got the inspiration. And then I got an opportunity here at Bhumi Armada to integrate do marine integrations for 21 megawatt into 11 kV gas turbines. So this is where we have this DFD technology where electric propulsion is there. Gas turbines, I've seen the efficiencies are much better, less OPEX. And I felt sad that it has not been adopted. We should think in those lines, you know, uh, look
Maybe
at
the
different.
capex is very high, probably.
No,
It
sir,
wasn't,
actually, if you
actually, it
see,
wasn't.
it
It
is just the
wasn't.
inertia. It is just the inertia of the industry, sir. It is
wasn't.
not that it is very high. The diesel engine, the cost of the lube oil which a diesel engine basically burns, cylinder plus the system lube oil. And if you see the HD grade lube oil cost is about 30 times the installation cost of the plant. Compared to that, the gas turbine work runs generally simple turbine oil. And I would also like to add to what Disha sir says. I had a junior of 2007 pass out batch, Mr. Agarwal. I'm forgetting his name. My memory is failing me. He has done the master degree in rotodynamic machinery from ISS. Then he went to United States, joined a very small company called the Rolls Royce, and then after that, he had been designing gas turbines for a long time. He has come back to India. I think he is teaching one of the institutions. So we have got a talent pool who are basically specialists in gas turbine. The major challenge today, what we see in India is the GTRE project, is the development of the monocrystal blade in the power turbine stage. So if we can basically get such talent, we can contribute to national objectives also.
Thank you, Nikhil. Thank you so much. Thank you,
I
Henrik.
do have one last question, Prakash. Are you all going to be subject to some sort of carbon tax in the marine industry if you don't meet these carbon dioxide reduction targets?
Yeah, it's going to come soon.
Okay.
Anyway,
Sir,
thanks, Prakash. Rahul Tiwari here. Look, Duke.
Hi, how are you, Raul?
Fine, boss. चलो अच्छा हुआ मिलके दोनों से.
I have been watching you, sir, on your Facebook all the time.
How's your daughter?
All good, sir.
Okay, thanks. चलो. Okay, Luke. See you sometimes in Australia.
Yes.
Bye.
Back to you, Pratik.
Sir, actually, I have one more question, sir, since this carbon tax topic came up. Sir, I mean, considering this economic burden of this emission pricing, which is coming recently with this EU ETS, and I believe in future and many other countries will also start implementing this
IMO
taxes.
itself is going to come with carbon tax.
So, sir, I mean, as a shipping company, sir, can you propose any, strategies that can be implemented to, reduce this economic burden of this emission pricing?
You have to use the energy saving devices. Reduce. It
Simple
has
as that,
to.
sir. EOI, but he has used it very carefully. We have just been filling up forms and submitting. Rather than that, if we take the hull efficiency and propulsor efficiency more seriously, I think it will go a long device. The framework is there, sir. Because
It
the
has to be
GHG
done.
protocol is there in Annex 6 from last 10 years.
Yes, but no one has been implementing it. So now comes the tax. So you're forced to do it. Your numbers will be counted. The owners will see, the charters will see, and then everybody down the line will start working to reduce it. You know, nobody works without stick. That is why stick is going to come.
So, sir, if you see any vessel which is like more than 15 years of age, I mean, now the retrofitting of this alternative fuel, it will be a much costly deal. So, I mean, anything for those vessels in order to let them trade in the future? Any strategies apart from this ESD like PBCF, EcoStater, anything else that can be implemented?
See, after 2030, the ships which are 20-year-old today, after 2030, they need to be phased out. Whatever you put on board is not going to help you much, because the investment what you're going to make at the age of say 20 years will not give you, your ROI will not be there, which will make your economics work. So 15, 20-year-old ships now are going to having problem next from 2030.
Sir, may I ask one thing, sir? I had been consultant in Gujarat for some time, and people here generally don't like to let go things. So I had done retrofitting of several propellers to coat nozzle. That is a normal 4-bladed, 5-bladed propeller to a pure
Correct.
Kaplan type steerable coat nozzle. and they gained at least 3 knots of speed. And not only that, sir, their consumption came down. So even if you do a proper smart analysis of the propulsion and powering, you will not only save the tax, you will earn money, and the metro modification will pay for itself in next 5 years plus more.
Yes, this is already a very popular way to improve efficiency. It's already happening on the big ships.
Okay, sir. And sir, one
Already
more.
they are fitting this kind of nozzle. The name is different, but yes, already being done. Even on our LNG ships, we have this.
Sir, if we leave these gas tankers like LNG, LPG, they are using their own cargo in the burning of main engine and generator. If you consider like oil tanker and other fleet, dry fleet, in order for them to survive in the future with regards to the carbon emission, how they would compete in the market with these regulations? Installation of this separate tanks for LNG, this alternative fuel, it is not so much popular in today's maritime world. As you said, for Maersk backed out on this fuel because they had to transport this methanol from Rotterdam to Suez for their bunker.
No, it was not only for that cost. Mainly the production cost they found was quite high, and whatever way of production is available now, they are not seeing that the cost can be reduced in near future. So that's why they ordered 62 LNG powered container ships now, just this year. 19 methanol and remaining 62 they ordered new is LNG. So the way forward is that we'll have to go for retrofitting. And when people ask me what kind of engines should I go for, ammonia, methanol, LNG, what? So all my new owners, I'm telling them, you go for the best engine. Don't and take any notation. Take ammonia notation, take LNG notation, take whatever. Wait for until 2030. So in your ROI, when you're making the plan, you make 2 months off hire after 5 years from today for retrofitting of the kind of engine available, the kind of fuel which comes out to be available now. If after 5 years it is clear that we'll have biodiesel, don't do anything. Just have a notation, that's all. But if you see that after 5 years, ammonia has now proven method to be produced at lesser cost, go to ammonia retrofit. You see methanol, go to methanol. You see hydrogen, go to hydrogen is okay. Not possible for 2 strokes. I will not say hydrogen anything. But that is what should be done today for new ship orders. So many of our owners have ordered ship with only notation. They have not gone for methanol or ammonia or LNG.
Okay. In terms
today
of
investment, they have a plan of 2 months off hire after 5 years.
So, but if you see the cases like in cases of retrofit, I was working with Nakilat on their Q Flexes and Q Maxes, one of the largest gas carriers. They decided to go to change one of the vessel, and they had all ME engines. They decided to change one ME engine to MEGI concept. They chose one of the Q Maxes, Rashida, and they did that thing. The initial.
I know, I'm aware of that.
Initial expenses which was thought, the final budget was almost 3 to 4 times than what it was expected. So then they decided to stop it. And now, none of their other vessels, they went for the retrofit. So,
but this
retrofit is not a viable option, I think, sir. Because retrofit only propulsor side, you can change prime mover changing in an old vessel with new pipelines, new high pressure things, new plant will be, I think, a technical and economical challenge unless and until soft loans or tax havens are given. Number 2, sir, I think now the trend is towards alternative fuel engine because Maersk has ordered 23 ammonia ships.
No, I have no knowledge of that.
That is what I saw from website. I may be wrong, sir. I can be correct.
No, so what I'm trying to say here and what Utkarsh is saying, see, QMAX case is different case. They fitted all ships with relic plant, right? And then Cell decided to do one ship as a trial changeover to the Megi.
Yes.
So just don't compare QMAX. You see, BW retrofitted their 21 LPG ships to LPG fuel, right? VLGC, they retrofitted. I don't hear any problem from them, you know. So all this concept is not correct, because you see, as a class surveyor or any class surveyor sitting here, every 5 years ship is supposed to be back to new. That is the concept, you see. So it is difficult, not right to say that retrofit is not good, not safe. Things, it is possible. It is not possible. It's already being done in large number. You go to China, like Xenia Shipyard is doing every month 2 to 3 ship for methanol conversion for Musk. They're already doing it. They're doing it. So I mean, it is out of contest right now there. This was only a normal, easy talking blog. But I think, Prateek, it was really very good participation from everyone.
Thank you, sir, for joining in, and thank you everyone for joining in.
And please keep in touch, Prakash.
Yes, sir. I will. I put on the chat what I received, but I will try to write to MA and ask them from where they got this figure. This is exactly from this slide.
No. In any event, just to keep in touch about your line of work, because some of the guys asked about the future. I think if more of you got involved with environment, I think you'll find that there's a lot of jobs in there. I've been working in the field for 30 years, and there's absolutely flush with the work that's coming out, because there's so many questions. We only have jobs if people have problems, and this is one of the biggest problems in the industry today.
Correct. You're right, sir. Thank you.
Thank you very much. I've got to go. Thanks so much. Thanks, guys.
Thank you everyone for joining, and thank you, Prakash sir, and all the seniors and juniors who have joined today. See you next week, same time, same place. Stay happy, keep smiling, keep sailing.
Thank you, sir.
Yeah.
Thank you. Thank you. Bye-bye.
Thank you, Prakash, sir. Thanks a lot for your help, sir.
Thank you. Thank you. Bye.
Bye.